3, 2, 1. And we are live. Hello, everyone who has joined us today or who will be watching this later on YouTube. I am Juliana Fagiardini, and today we are here with our first webinar for our Pre-SuriCon webinar series, which is a warm-up of sorts to our 10th SuriCon, which will happen this year in Madrid. This webinar is okay, it's working. This webinar is brought to you by the Open Information Security Foundation, also known as OISF, which is the foundation that maintains and supports Suricata. So OISF is a US 501c3 nonprofit organization that ensures that Suricata remains world-class. It is dedicated to preserving the integrity of open source security technologies and the communities that keep them thriving. Our team and our community includes world-class security and nonprofit experts, programmers, and industry leaders dedicated to open source security technologies. Funding for Suricata comes from donations from world-class security organizations committed to our mission, and a list of these organizations is available on our consortium members page. And one thing that I wanted to talk a bit about briefly is where this idea for the Pre-SuriCon webinar series came from. So you may have heard us speaking about this on social media, but this year we had a record number of submissions for our call for talks for SuriCon, and we did all we could to fit as many talks as we could during the 3 days agenda, but it was impossible to fit all the talks that we were interested in hearing. On top of that, some of those we thought would benefit if they had a longer format, which is something that the webinars offer. So what we have decided to do was to invite the speakers whose talks we really wanted to hear, but we couldn't fit, for them to present webinars with us. And they will also be invited to be present at SuriCon. So if you like the topic of this or the upcoming webinars and you would like to discuss more with the speakers and you join us for SuriCon, you will have the chance to talk with them live. We will be having webinars from now August until October, so it will really be a warm-up series before SuriCon. And of course, as always, these talks will then go to our YouTube channel. So in case someone has joined us and doesn't know what Suricata is, very brief explanation. It's a network security tool that is far more than just an IDS or IPS. So it works as an intrusion detection system and as an intrusion prevention system. It works on the cloud and on premise. It generates alerts if you have rules. It can, as I said, protect your traffic if you have it inline IPS mode, but it will also log protocol transactions. It will log network flows, which allow you to correlate events on your network. It does normal and conditional pickup recordings, and it can extract files from the transactions that it sees. And today's presentation will be conducted by Amine Berqia and his team. They will be talking about Smart IDS and improving Suricata's performance using machine learning, but I'll leave them to better introduce themselves and the topic. So the floor is yours. Thanks for joining us, and thanks Habiba, Usama, Amin, and Manar for being here with us for this presentation.
Okay, welcome everyone. First of all, I would like to thank Juliana and Kelly, even if she's not with us, but she was my first contact with SuriCon, to giving us this opportunity to share with the attendants our ideas. And after the presentation is for us is the part more interesting is the discussion part, the QA part, which is very interesting for us. And we will try also to attend SuriCon in November to make more networking. In this project, we are used in our institution, University Mohammed V in Rabat, and the engineering school ENSIAS, with our student from security of information systems and cybersecurity. We are used each year to propose some projects to work on. And this year, the idea was how we can improve IDS and IPS using artificial intelligence, especially this year was machine learning and deep learning. And as we are used to use Suricata, and for us, Suricata is a good tool for security, we focused more on the IDS, Intrusion Detection System, than Intrusion Prevention System. The result that we will show is more about Suricata as IDS. And now I would like to ask Osama to share slides, please.
Let's give Osama a few moments to adjust things. I was just saying before we started that Zoom changed the way we share screens, and now every time I have to do it, I spend way more time than I should. I get embarrassed.
Let's go. So the team is composed by myself and Habiba, who just finished her PhD last month, and two engineers, students that are Osama and Manar. They did a good job. The work on the project was for 3 months, and I think for 3 months they did well. And we have some interesting results for 3 months. I'm talking just about a project who had no budget. We worked just with the own materials and Suricata. And I think the results we obtained are very interesting and promised. And if we can have more collaborations, more budget, we can do better. So I would like now to ask Osama and Manar to take the floor and start the presentation from the beginning. Osama, could you back to the first slide?
Yes, thank you, sir. One moment, please. So let's start.
Yeah.
So imagine a world where your network is not just protected, but intelligently guarded against the most sophisticated cyber threats. Our project aims to bring this vision to life. To guide you through this vision, let's start with an overview of our presentation. We will first introduce our team, followed by the project's background, which provides the motivation and foundation work. We will then dive into the technical details, showcase our implementation and use cases, and finally, summarize our finding in the conclusion. Let me present our team. Leading our efforts is our esteemed PhD professor, Amine Berqia, whose extensive research and expertise in cybersecurity provide invaluable insights and direction. We are also supported by Habiba Bouijij, a doctoral researcher with a deep understanding of advanced cybersecurity technologies. I am Usama Ismaili, and together with my talented peer, Manar Shabi, both cybersecurity students at ENSIAS, we bring passion and innovation to this project. In this brief presentation, we will explore the concepts of Smart Intrusion Detection System. There's transformative potential in cybersecurity. Let's begin by examining the limitation of a traditional IDS. Well, traditional signature-based intrusion detection systems are increasingly proven inadequate in the face of new and sophisticated cyber threats. Their resilience and predefined signatures makes them ineffective against novel threats. To address this gap, our project uses advanced technologies such as machine learning and deep learning to develop IDS that not only detect but also predicts and adapt to emerging attack patterns. Our projects explore the potential of machine learning and deep learning to address the limitation of traditional IDS. These models analyzes the vast amounts of data to identify patterns and anomalies that signify potential threats. Let's walk through the process of our Smart IDS works. The process of our project is as follows. The process begins with an intrusion attempt or malicious activity. The intrusion attempt is first analyzed by Suricata, which examines traffic against known signatures and patterns. If Suricata identifies the intrusion as known, it triggers an alert. Otherwise, the data is passed on to an AI model. The AI model further analyzes the traffic to detect unknown intrusion patterns. Based on the AI model's analysis, alerts are generated for detected anomalies. As we address the process, it is important to highlight the specific challenges that motivated our project. We chose to work on this project due to several compelling reasons. First of all, the complexity of attacks. The digital landscape is evolving, making cyber attacks more sophisticated. Our project integrates machine learning with Suricata to adapt to these changing threats. While dealing with complex attacks is crucial, another significant challenge we face is the high false positive rates in the current IDS solutions. Current IDS solutions often produce high false positive rates, overwhelming security teams. Our Smart IDS reduces false positives through advanced machine learning techniques. And beyond reducing false positives, it is also essential to improve the accuracy of the threat detection. Traditionally, IDS struggles with the new attacks due to static rules. Our project will improve detection accuracy with machine learning models that continuously learn from extensive data. In addition to improving accuracy, we must also ensure our IDS can handle large volumes of data generated by modern networks without any performance loss. Our IDS handles large data volumes efficiently, ensuring real-time analysis without performance degradation. With these challenges and solutions in mind, let's examine how our Smart IDS improves specific aspects. First, let's talk about threat detection. Traditionally, IDS uses rule-based detection, which is static and struggles with new threats. Our AI-enhanced Suricata uses machine learning to continuously adapt and detect previously unseen threats. It is also adaptable. Traditional Suricata requires manual updates, while our AI-enhanced system autonomously refines its detection capabilities. And finally, the performance impacts. Traditional systems may suffer performance degradation with large data volumes. Our system uses a synchronous process and optimized algorithms to maintain performance. To see how these improvements are implemented in practice, we'll explore the Smart IDS monitoring analysis. Let's start with Suricata, a robust IDS engine that continuously monitors network traffic. as it processes network traffic, generates detailed log entities for each detected event. These logs provide a wealth of information about potential security incidents, forming the foundation of our subsequent analysis and response efforts. Now that we understand how Suricata monitors and logs network traffic, let's move on to how we handle and process these logs efficiently. To handle the vast amount of log data generated by Suricata, we implement asynchronous operations for real-time log processing. This approach ensures that log handling does not block other critical tasks, allowing for continuous and efficient processing. By processing logs asynchronously, we can extract features and analyze data in real time, ensuring timely detection and response to potential threats. With our logs being processed in real time, next step is to extract relevant features that provide insights into network behavior. Next, we will focus on feature extraction from Suricata log entities. This step involves extracting relevant characteristics that describe network flow and behavior. These features provide insights into the nature of the traffic and help identify patterns that may indicate potential threats. By analyzing these features, we can gain a deeper understanding of the network security posture and detect anomalies efficiently. After we apply advanced machine learning models to analyze the data further. With the extracted features, we apply pre-trained machine learning models to predict potential threats. These models are designed to analyze the data and detect anomalies with special activity. This special activity that traditional signature-based methods might miss. By using machine learning, we enhance our detection capabilities, identifying threats that could evade conventional detection techniques. Based on the insights gained from our machine learning models, we need to generate alerts to signal any detected anomalies. Based on predefined from machine learning models, we generate alerts for any detected abnormal traffic. These alerts are crucial as they highlight potential security issues that require immediate attention. By providing timely alerts, we enable prompt investigation and response, mitigating the impacts of potential threats on the network. Once alerts are generated, it's the administrator's responsibility to review and act on them. By following this workflow, we ensure a robust and dynamic approach to intrusion detection, combining the power of signature-based methods with the adaptability of machine learning. And now I will give the floor to my teammate, Manar Shebi.
Thank you, Sama. Can you take off like the presentation from the screen so we can do mine? Thank you. Can you see the presentation?
Yes.
Yes, it's a bit narrow. Okay, it's better now.
Yeah, it's good.
Yes.
Perfect.
Okay, thank you. So with more technical details, I'm sorry, I want to take off this one. Sorry. So with more technical details, as Osama said, we've used machine learning and deep learning models to implement it in Suricata just to achieve our mission, which is enhancing its capabilities. We'll pass right now to the next part, which is the integration of the method of the integration. So the integration, as you can see in this slide, has 4 steps, and we're going to say what is the method that we've used to implement machine learning after that. So the first step, as you can see, is the continuous monitoring. We basically continuously monitor network traffic and extract features from Suricata log entries. So that involves real-time analysis of network traffic to identify potential threats. Then we have the feature extraction and classification. We can say both of these things are in the second step. So we mainly the extracted features are fed into the pre-trained machine learning models, and also the deep learning models that we've trained. And then we classify the traffic as normal or abnormal, just as the traditional Suricata or the IDS that we have. So basically, the machine learning models such as RF, LR, and the deep learning models such as CNN analyze the data to detect anomalies. Then we have the third step. We can say that it is alert generation. So if an abnormal pattern is detected, an alert is generated for further analysis, which ensures that even previously unknown threats are flagged for investigation. Then we have the fourth one and the last one, which is the anomaly analysis and signature creation. And that's what we try to do from the beginning. So the analysis of anomalies helps to my colleague said, we have the signature-based IDS, and we want to turn it to the anomaly-based IDS. But the idea at the last, the idea is to make the signature-based IDS more, I don't know how to say it, but more like we want to create new signatures, and that by using machine learning models. So this dynamic approach allows Suricata to adapt, as I said, to new threats, to new intrusions by updating time by time its signature database based on the ML or the DL findings. And the idea behind this was writing a code. We've used Python, and that code helps to integrate machine learning and deep learning into Suricata. I can say some steps of the code and some key functions of the code. So I can give a small breakdown. The first step is the data extraction and pre-processing. Then we have the model loading, then the feature transformation and prediction, and finally the alert handling and anomaly detection. For the key functions, we have many functions in the code, but the key ones or the principal ones, I can give examples of the follow log function, which synchronously follows the Suricata log file, processes each log entry, and then triggers features, its extraction and prediction. We have also the extract info function. It basically extracts and computes various features from the log data, which are crucial for the ML and the DL models to make accurate predictions. And then we have also the function, the load models function, which loads and prepares the pre-trained ML and DL models, along with necessary scalars and encoders for prediction. And we have the prediction function that transforms features, makes predictions using the loaded models, and then interprets the results. So that was a small breakdown of the integration steps, the integration process that we've done to implement machine learning and the deep learning models. We can give you after that a sneak peek into the code to make more I don't know how to say it, but more improvements. And of course, that's why learning is here and knowledge is here. So we'll pass right now to the implementation and use cases. For our own implementation, we utilized Suricata version 0.03. Despite the latest version right now is 0.06. I don't know if I'm right, but I think it's the 0.06. But the reason for that choice of 0.03 is that our project commenced in February as a school project. It didn't intend to be as big as right now. I see the project as big because the future is for us. So we maintain the same version for consistency and stability, but we can work with the 7.0.06. For the hardware, we've utilized Raspberry Pi, and for the operation system, we've utilized we've tried many operation systems, but we've stick to Kali Linux at the end. And these tools provided a robust and flexible environment for developing and testing our Suricata, integrated after that with machine learning and deep learning techniques. So right now we'll pass to the configuration. Like it was so, I don't want to say it's so simple, but we've tried many IDS, and the one that works perfectly and the one that is used with in the society, the cybersecurity society in Morocco, is Suricata. So that's why we love Suricata. It was so not that simple, but simple to import, to install, to configure. So after inserting the SD card into our Raspberry Pi, we start it up and begin to interact with it. You can interact with it, as you know, either through a screen and keyboard or via SSH, as in our case. So the Raspberry Pi, I want to say that the Raspberry Pi has the necessary hardware specification to install and run Suricata without issues. But as I said, we've tried many IDS, and I think it's the all way around. Suricata has the capabilities to be run simply and easily on Raspberry Pi. So we start by downloading the latest version at that time, which is 7.03 from the official website, and just follow the installation steps. Then we import the standard pre-configured rules from the immersion threat websites, like for protocols like ICMP, FTP, IMAP, SMTP, NetBIOS, Telnet, and HTTP, etc. So after that, once Suricata was installed, it didn't take many time, it was installed. We configure it through the default configuration file, which is /etc/suricata/suricata.yaml, specifying the network interface to monitor. You can simply obtain this via ifconfig and setting it to the homelet. And we also specify the detection rules by adding the file names at the end of the configuration file under the rule file section. So if you have some custom rules, you can simply add this your custom rules by including a line like -myrules.rules. It is just that simple, so simple to use. And the default rules also are located in /etc/suricata/rules. And as I said, if a rule is needed, you can just add it by -myrules.rules. Then we start Suricata as a service on the Raspberry Pi, as you can see in this command, Suricata or sudo systemctl status suricata.service. And now, after configuring Suricata, installing Suricata, and doing many attack simulation, it was it worked perfectly. But when we've tried to test it with the data set that we had, it did, I will show you, it did detect some attacks, but not all of the attacks. We've concentrated on the DDoS and the DOS attacks. We're going to work on new attacks or more attacks in the future. But we're sticking right now to the DDoS and the DOS attack because, as I said, it started just as a school project, testing Suricata with the DDoS attack, DOS attacks, and then implementing machine learning. And here we go, attending a pre-webinar with the Suricata community. We'll pass right now to the part of the Smart IDS. So our main mission, our main goal is to enhance Suricata capabilities by integrating machine learning models, deep learning models. And as I said, we've tried the DDoS and DOS attacks. So after implementing the code that I've talked about, we do here's an example of a test we've tried to do a DOS attack or like sorry, using this command hping3-c, etc. So this command initiates a SIM flood, a type of a DDoS attack on the target IP address, which is, as you can see, 192.168.137.208. It basically sends 14,000 SIM packets, each with like a data size of 120 bytes and a TCP window size of 64 bytes to port 80, as you can see. The ports are sent like as fast as possible, but as you can see in this command by -- flood, and this potentially overwhelmed the target's ability to process new connection. And the source IP addresses of the packets are randomized, are just random. So we're using, as you can see, using the --rand source, and this makes it difficult to identify and block the source of the attack. And then we'll pass to the results that we had. So with like the data set, we didn't talk about the data set, but we've used the CIC 2023 data set of the Canadian Institute of Technology. Well, like it was like ready to be used, but we're currently working on a collaboration with two laboratory in our schools and our university. The first one is the drone laboratory, and the second one is the robotic innovative laboratory. So we're trying in the future, not in like in the near future, after these 3 weeks of holiday here in Morocco, we'll try to collect our own data using robots. And we've talked about with the administration that we're going to take the security side of these labs, and we're going to use Suricata and try to work more on this project, which is Smart IDS, because AI is everywhere. AI is, I forget how to say it, but we say in French, c'est la tendance. Donc, well, AI is just the trend, yeah. AI is the trend right now. And that's why we've chosen this project. So we'll pass to the result. As you can see, this shows the features of the data set that we have. We have, for example, the flow duration, the header length, the protocol flag numbers, etc. And at the end, you can see what was our results. So you can see in the outputs, like we consider the DOS SIM flood attack. It was detected only by the decision tree algorithm, and the DOS ICMP flood attack was initially detected by Suricata, but also identified by both the convolutional neural network, the CNN, and I have here an error by the CNN and the RF, and then the DOS ICMP algorithm, it was detected by the RF algorithm, while the CNN did not. So we're trying to enhance these results, to work more on a bigger data set, and we honestly tried to do the best during these 3 months, doing the best with our own PCs, our own laptops. It was quite difficult to do that, because, you know, training the data set and doing all of these processes needs time and needs a good one. But we've talked with the administration, and we'll have like the devices that we are needing in the project. So the last one is the Benin traffic. It was, of course, detected by Suricata, and it was detected by the CNN and the naive bias algorithm. And by that, we have the conclusion. So as you can see, Suricata has shown itself to be like a reliable and an effective tool for network security. However, we believe like there's still room for improvement, particularly by integrating artificial intelligence and machine learning. As I said, machine learning, AI is the trend. So, and we are students, we are always students, and we want to learn more. We want to enhance all the technologies. We want to enhance our own capabilities. So our main goal is to continue like to seek ways to enhance our study. And given the opportunity, given like presented by SuriCon, we decided to take a shot at it and to complete this project. And in our project, we've tested various machine learning algorithms, including DT, decision tree, logistic regression, ALER, naive bayes, convolutional neural network, CNN, and also random forest that shows like near to perfect accuracy during the study. So we assessed these algorithms for their accuracy and ability to distinguish between like different classes of network traffic. And our findings demonstrate that incorporating ML and DL can significantly boost Suricata's capabilities in identifying and, of course, responding to network threats. And thank you for the opportunity and for your attention.
Thank you, Manar. Thank you, Osama. So as I said in the beginning, our presentation will be around 30 minutes. And now I will give back floor to Juliana to manage the questions and answer session, all part of the webinar.
Thank you all. Lukasz, as I've done the introduction, do you want to run the Q&A?
Sure. All right, so we got a first question from Jason. And basically asked, it looks like, and I think you mentioned that you were reading outputs from Suricata outputs. So you actually did not need to touch Suricata code. You just basically used Suricata outputs like if the JSON or fastlog and files like this to input this data into your model. Is that correct?
Yes, we just used the outputs of Suricata. We didn't touch it.
Did you use that all in your Python program?
Yes, we used that like if for JSON.
Right.
We collect data from if for JSON.
Can you collect these data live, or was the workflow like you process the PCAP with Suricata that outputted the if.json, and then you process the if.json with your program, with your model?
We process if for JSON directly in our models. We use asynchronous operations to keep the process perfect.
Okay, thanks. Jason also concluded that it's great to see that you are utilizing Suricata outputs already, and you did not need to touch the code base.
Yes, we found all the information in if and we use this.
Okay. You also mentioned the data set. So am I correct that you used CIC data set to train the model, and then you verified the correctness of your model by the hping command, let's say, or?
We did the train and the tests on the we took a part from the data set to do training, and after we took another part for like 70%, 30% for testing, and after we tested using HP3.
Okay. Do you also have some, did you collect some other results as like false negatives, false positives and other metrics as well?
Yes, there was also like they were reduced, just not like before. But we didn't take like screenshots like this one.
We can provide you with like more details, like a small report of our study after that.
Okay, that was actually the second question from Jason. He actually asked if this project can become public at some point. So we would be glad to see that. If you can link us either report or a GitHub repository, that would be perfect.
Okay.
Next question is from Vagisha. How did you manage storing real time if the JSON, pre-processing it and using it in training models? So, and was the model retrained or fine-tuned if the alert was identified as normal? So I guess maybe this comes back to the question, if you first run the PCAP, run Suricata on the PCAP and only then run Suricata on it, or if you did it live, basically.
As I said, we use asynchronous operations to not block Suricata's workflow, the original workflow. So we read from if on JSON in real time.
Okay. And did you need to somehow fine-tune the models as well?
Yes. Can you repeat, please?
If you had to fine-tune, or how did you fine-tune your models? Meaning, I guess on the first try, as you run basically the training data set on the data, it was not perfect from the first try. So somehow you had to adjust the model a little bit here and there. So what was your process in this regard?
First of all, we used like not the all data set from the CIOT institute. We chose the specific data, not all random data gave us best results. So we kept searching for the right data that gave us the right results.
Okay, Vagisha, sorry, did we answer all your questions? In the meantime,
Juliana, you don't have questions?
in the meantime,
I'm waiting.
I have one more question from Peter. He couldn't type to QA. So how long did you need to train the model?
It depends on the models. There is models that took more time than the others. Can you specify a model so I can give you?
Sure, like the convolutional neural networks, for instance.
Like okay, CNN will find. But CNN, I guess, was the first one, not like the others. I will find the time.
Actually, the study shows that deep learning algorithms worked like better than the machine learning algorithm, especially when it comes to
This is normal. Deep learning will work better than machine
yeah.
learning.
when it comes to training, and so like it worked perfectly. And as Osama said, we didn't use all of the data set due to our to the weak capacities of our laptops and our PCs, but we're working on the virtual machine of our school right now, so we're trying to train more data sets. It took a while to train the data set, and it took Osama will tell you the specific time for the algorithms to be like to in the life, like before the live deployment.
Right. Okay. And so the command that you showed, the hping command, did you use that also in your study, or is if I get it correctly now, you use primarily the CI CE dataset?
Yes, we did use the CIC dataset, and we used the hping command in our study.
Okay.
Would it be possible to share some of the rules that were updated or created with this interactive process?
You can.
Just Osama and Manar, you have to explain more the module and to say that we didn't change anything in Suricata, but we add another module to do what we need to do, okay?
Yeah, exactly.
Yes, but you said that one of the steps would be to like you have your first rule set, right? And then it would be possible to create new rules for using your model. Did this step actually happen? Do you have any rules that were created like that you could share with us?
No, not yet. We didn't create.
Okay.
It was like just like we just want to say that Suricata is a rule-based IDS, and it's so simple to add a custom rule if you need it. Like it's simple, so you can just add that rule. But in our study, we didn't do that yet.
Okay. One other thing. Did you miss anything from our logs that would have made your process easier? Did you feel that we were lacking any output that would be be beneficial for the training?
On this dataset, the current dataset, we found all the features in the logs.
Yeah, but did you wish some other feature was in the logs that was not? Like, oh, I really wish that I had this information. It would make things so much easier, and it was not there.
No, I don't think so, because if we didn't find like a feature, we're like we will ask for that one. But
Okay.
we found them all.
Maybe in the future.
So because the focus of the project was how we can detect vulnerabilities that Suricata cannot detect using our module based on machine learning and deep learning. It's just proof of concept. It was the project was more proof of concept, and I think we have good results in this kind. We have the proof of concept. Now we have to do more, our team, and I hope with the collaboration with SuriCon people, we can do better.
Certainly.
I have one more question. And what features did you use as an input to your models, to your machine learning? So,
I will answer that. With the lots, actually.
it doesn't need to be exact list, just the main ones, maybe.
Just give some
I will
feedback.
find it.
So just give some.
We used the timestamp, flow duration, protocol type, like this protocol type. Like there is a number, a standard number. The rate of packets, and there is another fin flag numbers. They are all in the presentation.
So hello, I can add one opinion for features extraction. We used random forests, and sometimes we used extra tree selected the function from scikit-learn library to select the better features in the data.
Okay.
I can share with you like a
I'm
list.
happy to hear you, Habiba, because Habiba is more French speaking. So she was afraid to talk to people today, but I'm happy to hear Habiba today. Okay.
We wouldn't even notice. So Manar, I think you tried to tell us something else.
I said like we can share with you a list of the features that has been extracted from the network traffic. I can share it right now.
Do you plan on publishing any papers with this? Because it would be, or in case you have already published and you could share with us, because there are so many details, right? And it would be cool to be able to check the data sets.
Yeah, we wrote the paper, is ready, and now we're just thinking if we will send it to a conference or to a journal.
Okay. When you do, please share with us.
Sure, sure.
Awesome. Okay.
It's interesting. Thank you.
Yeah.
And Juliana, if you have any idea on where we can publish it, we can send you the draft, and maybe you can read it and to join as a co-author.
I think I appreciate the invitation. Maybe Lucas and I could check that, because Lucas is finishing his PhD study, so he probably knows more of places to publish.
Yeah, Lucas, also we can work together on the final version of the paper. We can send you the first version to look to you, and you can share with Lucas. And if you think we can publish it somewhere interesting place, that's okay for us.
That sounds great. And if you do attend SuriCon, I think we also have, if I'm not mistaken, I think Vagisha is also working with something related to that. I think there could be interesting exchanges with you guys.
Yeah, we will try to attend SuriCon event,
hopefully,
as we can share with people working on the same topic.
If there are no more questions, I would like to thank you all for joining us today, and just a few final words. Let's see. I think there's Vagisha is saying, great webinar, looking forward to connect with you all at SuriCon. I'm also excited about that.
Thank you, Vagisha.
I'll briefly share.
And thank you, Juliana, for respecting time. That is good.
Well, you all did it, right?
When the link is already on YouTube, send it to me, please.
No worries, we'll do. And we will also publish on our social media as usual. So.
And all the links that we can share with our institution also.
Yeah. Once again, thanks everyone who joined. Thank you for.
As you saw in our communications, I'm not really very used with social networks, okay?
Yeah, it's fine. We will share via email as well.
I'm using just email and WhatsApp.
Okay. We want to once again invite everyone the speakers and the attendees to join us in celebrating our 10th SuriCon this year. It will happen in Madrid in November from 13th to the 15th. Before the event, we also have 3 different training sessions, each of those taking 2 full days, November 11th and 12th. You can check all of that information, including the agenda with all the other talks on suricon.net. If you want to join our community and you are not there yet, and you like social media, of course, we have our Discord and our forum where you can share questions and discuss more in depth about this presentation. For instance,
sorry, Juliana, to interrupt. I forgot to thank our dean, Mrs. Ilham Barada, who will allow us to attend SuriCon in Madrid, and she will give us the budget to do that. And so I forgot to thank her. Thank you, Ilham, also for your support.
Thanks a lot. It's very important to have support, to have research happening, right? It doesn't work without that. And for all of you, speakers included, who want to check our next pre-SuriCon webinars, the next one will be happening in August the 29th. It will be with Pim Sanders from Fox IT, and the topic is automating Suricata rule validation with, I think there's a typo on the title. I think it's differentiate tone and zoo. Sorry, Pim, I messed up with the webinar title. Thanks, everyone. It was a pleasure having this webinar today and kickstarting this series with you all. I hope to see you in the next. Thanks, Habiba, Manar, Amine, and Usama. Thanks all the attendees, Lukasz and Peter, for being the co-hosts here today. Do we have anything? We have 1 final minute.
Thank you, Juliana.
Thank you all of you.
Thank you, all of you.
I'm very happy for the success of the webinar. Maybe on 29, I will be in holidays. I cannot attend, but I will try to attend in Madrid.
Awesome, and
Well,
it will be also be recorded.
It would be even glad to see you all. All right, I think we can conclude with this, so I'm stopping the recording.